Good day! Welcome to Data Analytics Tools Series. I'm Dr. Danielle Morin from Concordia University in Montreal, Canada. And the session today is about k-means clustering, and we will illustrate it using frontline solver data mining. K-means clustering is in fact an algorithm that randomly partitions the observation into k-clusters. After all the observations have been assigned to a cluster, the resulting cluster centroids are calculated. This is like the midpoint of the cluster. And using the updated cluster centroids, when we move observation from one to the other, the observations are reassigned to the cluster when the closest centroid distance is calculated with the Euclidean measure. So let us take an example where we have 30 observations with 3 variables. They are age, income, and number of children. And we will use the k-means clustering to form 3 clusters. What makes good clusters is that the measure of similarity within the cluster is good and the distance between cluster is as large as possible. So let us bring our observations in Excel. Here is my set of 30 observations. So let us use this data set, and as before, using data mining, cluster, and we will select k-means clustering. A few information points will have to be considered. The variable under study will be age, income, and children. And the first row contains headers. Next information is whether we want to normalize the data or not. Since age, income, and children are presented with different units, it is much better to normalize the data. We will ask for 3 clusters, and we will ask for 10 iterations. That means observation will be reassigned one cluster to the other, and we will look at that during 10 times. We will use the random start. We will use 10 random starts, and we will have the seed at 1, 2, 3, 4, 5. Why do we set the seed 1, 2, 3, 4, 5 in my algorithm? The reason is that each time I will repeat the analysis on the same data set, I will get the same result. It's not going to generate new results. So at least I can verify and go back to my results. And then we will ask to show the data summary, and we like also to have the distance from each cluster. The first part of the report concerns the information we have put into the system. We have 30 records, we have 3 variables, we want 3 clusters. We have used a random start and 10 of those iterations, and we have used an initial centroid of 1, 2, 3, 4, 5. We want to have the data summary, we want to have the distance from each cluster, and we want the observation to be normalized. The second part consists in the random start summary. Because we have 10 iterations, the initial seed that we have put in the system have generated 10 starts. And which one is better? It will be the one that will minimize the sum of square. And it is identified as start 3. Sum of square is 49.71, which is smaller than all the others. Therefore, this will be the start that will be used in the algorithm. Now we have 3 matrices of information. The second one is giving me the cluster centers. It is giving me the average value for the variable in each cluster. But keep in mind, these are the normalized value. The next thing is the inter-cluster distances, which gives me the distance between clusters. From what we can see here, the distance between cluster 1 and cluster 2 is the largest. It tells us that there is more difference between those two clusters. We see that cluster 1 and cluster 3 are not as different from each other as 1 and 2 were. And then the last table is about the cluster summary. It tells me how many observations are in each cluster. 15 in my first cluster, 5 in my second, and 10 in my third cluster. And the average distance within the clusters. So what can we say? We see that this cluster 3 has the smallest average distance within the clusters. So that means the cluster 3 is more homogeneous. Cluster 1 has more variation, therefore we can say it's more heterogeneous. But the information that I have from these three matrices does not relate directly to the original values. Look at the cluster labels. Observation 1 is 0.9879 from cluster 1, 2.73 from cluster 2, and 1.19 from cluster 3. Therefore, the smallest distance is 0.98. Therefore, we classify record 1 as belonging to cluster 1, 3. Now, let us see what it gives us when I take this classification and I will bring it to the original data that we have here. I have the classification of my original data. Now, to know how these things work and what is the membership of each cluster, what I could do is simply to insert a pivot table. I will insert a pivot table and I will use the clusters for the rows and the value for each of the variables. So income, then I will ask for the average income, and then children, average number of children, and I will ask also for the age, average age. If I look now at my table here, for each cluster, I have the average on the variables we were looking for. What do we note? We know that in cluster 1, the income is smaller, average income is smaller, average number of children is higher, and the average age is smaller. If I look at cluster 2, this is the highest income group. Number of children is at 1, and this is the oldest group of people with an average age of 61.4. Cluster 3 stands at the lowest number of children, the age, middle-aged people, and the income is also middle income. This will allow me to prepare services for the different groups of people. The younger one with children, the older one with a smaller number of children. So this is an application of the k-means clustering using Frontline Solver data mining. See you next time.